Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss about the feedback system, the types of feedback applied to our electronic circuits. What is a feedback? A feedback is a part of the output of any system which is fed back to the input is called a feedback system. Yes, I am just drawing a simple feedback system. Yes, the source signal is taken and fed to a comparator or an error detector circuit. This is an error amplifier or a comparator circuit which compares two input signals. One input signal is the source signal and the other input signal is the feedback signal. And this is the main amplifier. So a feedback is this path. A feedback is a fraction of the output taken and given to a system. Yes, beta is the feedback ratio, and here this signal coming out of this is the feedback signal. They both are compared, and the input signal, which is the output of the error amplifier, is fed to the main amplifier circuit. The output of this is an amplified output. A fraction of the amplified output is taken in the feedback. So this is called a closed loop system. A closed loop system. The forward amplifier is fed in with the input signal, and SO is the output signal. The process of injecting a fraction of the output energy back to the system is known as feedback. This has been found that the feedback is very useful in reducing noise, and also in case of electronic circuits, it brings out to be giving us good output. What is the principle of any feedback? In feedback, there are two types of feedback. One is positive feedback, the other one is negative feedback. What is positive feedback? If the feedback signal and the input signal are both in phase with each other, then it is called positive feedback. In negative feedback, if the feedback signal and the input signal are out of phase with each other, then it is called negative feedback. These kinds of feedback signals, depending on either the feedback signal is aiding or opposing to the input signal, they are classified as positive feedback and negative feedback. If the feedback signal aids with the input signal, then it is called positive feedback. If the feedback signal opposes with the input signal, then it is called negative feedback. The feedback voltage Vf is equal to beta into V naught, the output voltage. Yes. So here, this kind of signal, positive feedback, is fed to oscillators in which the feedback signal and the input signal will be aiding each other. So examples of positive feedbacks are oscillators. Examples for negative feedback systems are amplifiers. In amplifiers, the feedback signal and the input signal oppose, and hence they are called negative. And examples for negative types of feedback are amplifiers. I will just draw a simple block diagram to explain the principle, and will try to find out or calculate the gain of the feedback system. Yes, some signal is fed to an amplifier circuit, and we will be getting some output voltage, the source voltage Vs, and we have the feedback part of the circuit. This is the feedback block. A fraction of the output is taken and fed to the feedback block. This is connected to the input. So this is Vf, and this Vf will be equal to beta into V naught, and the input voltage signal to be amplified is fed to the amplifier. For a positive feedback, the input voltage is equal to Vs plus Vf, which is equal to Vs plus beta V naught. This is for positive feedback. And for a negative feedback, the input voltage Vi is equal to Vss. Source signal minus the feedback signal is equal to Vs minus beta V naught. And beta is equal to the feedback voltage divided by the output voltage. Yes. What is a positive feedback? The feedback in which the feedback energy, that is either the voltage or the current, is in phase with the input signal, and thus it aids, is called a positive feedback. Though the positive feedback increases the gain of the amplifier, it has a disadvantage like increasing distortion and instability. The overall gain of a positive feedback amplifier is given by AF is equal to A divided by 1 minus beta AV. AF is the feedback gain and A is the voltage gain. AF is equal to the voltage gain divided by 1 minus beta AV. The positive feedback is not recommended for amplifiers. If the positive feedback is sufficiently large, it leads to oscillations by which oscillator circuits are formed. Hence, these kind of positive feedbacks are fed to oscillators or multivibrators are excellent examples for positive feedback. Here in this oscillator and feedback, we connect a feedback loop which will aid the input signal. Now moving on to negative feedback. The feedback in which the feedback energy, that is either the voltage or the current, is out of phase with the input and thus it opposes it, is called negative feedback. In negative feedback, the amplifier introduces a phase shift of 180-degree into the circuit, while the feedback network is so designed that it produces no phase shift. No phase shift, or we can also tell that it has zero phase shift. Thus, the resultant feedback voltage Vf is 180-degree out of phase with the input signal Vn. The advantages of negative feedback are the stability of gain is improved. Stability is improved, very important parameter. Reduction in distortion, reduction in noise, increase in input impedance, and decrease in output impedance. These are the various advantages of negative feedback. So using this characteristic of negative feedback, they are employed in amplifiers because amplifiers require these kinds of properties. So there are two main types of negative feedback circuits. One is negative feedback. They have negative voltage feedback and negative current feedback. Negative voltage feedback. What are negative voltage feedback loops? The voltage feedback fed back to the input of the amplifier is proportional to the output voltage. Yes, there are two types of negative voltage feedback. The voltage fed back to the input of the amplifier is proportional to the output voltage. So there are two ways by which you can feedback. Either the voltage can be fed back in series or the voltage can be fed back in parallel. So if the voltage is fed back in series, it is called voltage series feedback. And if the voltage is fed back in parallel, then it is called voltage shunt feedback. The current feedback here, the current fed back to the amplifier is proportional to the output current. Then the current, if it is fed back in series connection, then it is called current series feedback, and the other is the current is fed in parallel to the input, then it is called current shunt feedback. So we will be discussing about these four types of feedback amplifier in the forthcoming video. So there are four types: voltage series, voltage shunt, current series, and current shunt. We will be discussing them one by one. Voltage series feedback. Yes, so the very important part of the understanding here is the way by which the voltage and current are fed into and from the feedback system. The output load resistor is connected at the end. Yes, so it's a voltage series. The first term voltage tells the output connection and the series tells the input connection. So it is voltage parameters always connected in parallel. So parallel connection is made in the output section. It is fed back to the feedback section, and as I said, the series input series connection. So this is the input signal. Here there's a source signal. Yes, and this is the V0 value. Here Vf is equal to beta into V0. The input voltage and the feedback are applied in series to a voltage series feedback amplifier. This kind of feedback is used to increase the voltage gain, reduce distortion, and improve the consistency. Feedbacks sum of the output voltage in series to improve precision. This controls gain, reduces distortion, and enhances the signal's precision overall. Yes, we'll go to the second type of feedback, voltage shunt feedback. Yes, voltage shunt. The output is a voltage connection and shunt input part should be a shunt connection. So both ways, parallel way of connecting. This is the amplifier stage and this is the feedback stage. Yes, so both ways connecting in parallel, voltage, and this is the load resistor fed back to the network. So both ways feedback. So Vs, Vn. Here Vf is equal to beta into V0. So in a voltage shunt feedback amplifier, the input voltage and the feedback are connected in parallel. This type of feedback is used to increase the voltage gain, enhance linearity, and decreases the output impedance. The enhanced stability by in parallel applying a portion of the output voltage to the input. As a result, the performance is improved under a range of situations by increasing the linearity and decreasing distortion. So next we will move on to the third type of feedback, current shunt feedback. So current output should be a series connection and the input should be a shunt connection. So we need to make up the block diagram in such a way that this is a current amplifier, output in series. So a load resistor connected in series to the feedback. And in the input, the voltage is, yes, this is the current, the source current. I flows into this. VA is a voltage drop across, and I naught. Here, the feedback current IF is equal to beta into I naught. In this kind of current shunt feedback, the feedback and the input current are applied in shunt to the input. It is a common practice to use this type of feedback to increase the stability, input impedance, and bandwidth. This increases stability by running in parallel some of the output current. This improves linearity, lowers distortion, and gives the amplifier's characteristic more control for reliable performance in a range of scenarios. Yes, this is about current shunt feedback. We are moving into the last type of feedback, current series feedback. Current series, this a series connection in the output part and a series connection in the input part of the amplifier as well. So this is the amplifier. The feedback block RL, yes, this is IF. You can either connect voltage source or current in parallel. So the feedback in a current series feedback is connected in series with the input. This arrangement is frequently used to increase the bandwidth stability and input impedance. This also controls the gain, guarantees precise amplification, and reduces distortion for an enhanced integrity of signals across a range of applications. Now we'll discuss about the frequency response of a feedback amplifier. The frequency response plot is drawn with frequency on the x-axis and the gain in decibels on y-axis. The feedback amplifiers behaves such that at lower level of frequencies the gain increases, remains constant for a wide range of frequency, and then as the frequency increases the gain reduces. So reducing a 3 decibel gain from the maximum, the cutoff frequencies are calculated, F1 and F2. This is a range of minus 3 decibel in order to observe the cutoff frequency. Yes, the bandwidth is calculated in this manner. upper cutoff frequency is F2 and the lower cutoff frequency is F1. The bandwidth of the amplifier circuit is calculated by the upper cutoff frequency minus the lower cutoff frequency. This is also called higher frequency corner and lower frequency corner. The frequency here is in hertz. Yes, so this loop is called positive slope and this slope is called negative slope. Yes, we are towards the end of this topic of feedback amplifiers. Feedback amplifiers, there are two types to summarize. We have positive feedback and negative feedback. Based on the nature of the feedback signal, if it is in phase with the input signal, then it is called positive feedback. If the feedback signal is out of phase with the input signal, then it is called negative feedback. Being having such characteristics, positive feedbacks are employed to oscillators and multivibrator circuits. Negative feedbacks are employed to amplifiers. In negative feedbacks, we have four types of connections by which you can make according to the necessity of the load requirement. Voltage shunt feedback, voltage series feedback, current shunt feedback, and current series feedback. We have also discussed the frequency response of the feedback amplifier circuit. Thank you.